So welcome to VMYC, and today we are going to see the second chapter of Swamiji Vedic Mathematics book. The chapter is related to the multiplication by Nikhilam Sutra. In this chapter, Swamiji was used Nikhilam Navataha Charmam Dashataha Sutra. It means all from 9, last from 10. So this sutra is very useful for the finding very important part of the multiplication. First of all, let us see how to use all from 9, last from 10 by few examples. And nowadays, Nikhilam multiplication we are called as base multiplication. Base method multiplication. So what is the base? So base is nothing but here we can say that is 10, 100, 1000, 10,000 up to so on 10 power n, where n is natural number. N is natural number. And sometimes the base we are called as theoretical base also. Theoretical base. I will tell you where we are using this theoretical base name. And subbase also we have in Vedic math. Subbase is nothing but multiple of base. That is nothing but k times of 10 power n, where k and n are belonging to the natural number only. For example, 20, 30, 40, 50, up to so on. All these numbers are multiple of 10, or 200, 400, 700, 1200. If you look this example, or everything will be multiple of 100. Suppose if you are taking 1000 multiples, 3000, 7000, 13,000. So these are all the multiple of the base. So that is the reason we have called it as sub-base number. Okay. I hope you understand base and sub-base concept here. Okay. Now what we are doing here first we are going to see the Nikhilam Navataha Charman Dashataha concept. It is nothing but a subtraction from the base number. Right. For example, subtract any number from the bases. 100 minus 24, 1000 minus 386, 10,000 minus 243. So these kind of subtraction we can easily find by using Nikhilam Navataha Charmam Dashata. Swamiji is saying that when we have base subtractions, we have, then simply first number we are subtracting from the 10, so that we are getting 10, and the remaining number all from the 9. Here last from 10 means it is the indicates the unit place digit, and the remaining digit will be subtracted from the 9 only. So this number if you are subtracting from the 9, then you are getting 7. So in generally when we are borrowing the number, so this will be, one will be cancelled, it becomes 0. So when we have dealing with the bases, one always eliminated. So this will be the 76 answer. The first number from the 10, 4, the second number from 9, and the third number also from the 9. Then we are getting 6. So this will be the final result, and this one will be eliminated. And here it will be from 10, 7, from 9 it will be 5, from 9 it will be 7. But look at here, every time we have to very focused on the how many zeros we have in the base, that many digit will be there. So that is the reason I'm writing the 0 here to equalize the number of 0 to the number of 0. So from 9 it will be 9 only. 9 subtraction that will be. So only the first digit we are subtracting from the 10, and the remaining digit everything we are subtracting from the 9s only. Then answer comes out. And if you use the different terminology, 24 is 76 less than the 100. So it is less than the 100. So we can say that these numbers in another way we call as deficiency or deviations. Okay, deficiency or deviation. This is the deviation we are using in the multiplication problem. Okay, so what is the deviation? Let us see everything in the next problem. Okay, right. Look at here. Swamiji here took 9 into 7. And Swamiji written -1 and 7 as -3. Look at like this. These numbers we call as deviation. So how to find the deviation? Let us see now. So deviation is nothing but given number minus base or subbase. So this is the deviation formula. Suppose 9 is there, 7 is there. These two problem very nearest to the 10. And another point also I'm mentioning here. Nikhilam method we are using when multiplicand and the multiplier are very nearest to the base and subbase, then only we can calculate very fastly. Of course, given multiplicand and multiplier very far from the base number, then also can be solved, but it look like complicated. So we are focusing the numbers we nearest to the base one. So 9 minus base will be you are taking 10. For both number nearest to the 10, so that is the reason I am taking base 10. So it will be -1 and it will be the -3. So in this way, we are finding the deviation. I hope you understand. This is the given numbers and this is the nearest base and this will be the deviation. And the answer will be divided into two parts. One will be right part, another will be left part. In the right part, we are writing a product of the deviation, that is -1 into -3. So that gives us 3 only. And in the left part, we are taking the cross subtraction. Why? Because Swamiji, before going to tell this multiplication symbol, old historical tradition, the cross subtraction procedure have been responsible for the acceptance of the into mark. It is a sign of a multiplication. So don't think when we are writing into mark, it is a not multiplication. Either it is a cross subtraction or cross addition. In this case, we are doing cross subtraction. Why? Because deviations are negative. Either one you can take, like 9 minus 3 you can take, or 7 minus 1 diagonally. In the both cases, we are getting 6. This will be the our left part. I hope you understand. Two parts will be divided, right part, left part. In the left part, cross subtraction or cross addition we are taking. And in the right part, we are taking the product of the deviation. But in the product of the deviation, number of digit will be fixed. Number of digit will be fixed. It is depends upon the number of zeros in the base. So here I selected 10 as my base. It having a single zero. So that means here we have only single digit. In the proof, I will tell you very clearly. First, just now you remember this point. How many zeros in the base, selected base? That many digit will be fixed in the right hand position. Remember this point, that's it. And this example is 9 into 9. Here 9 into 8 and it will be 9 into 6. It is 9 into 5 and 8 into 8, 8 into 7 and 8 into 6 and 7 into 7. And Swamiji just simply written the deviation, negative deviations like this from 10 base here. Okay. So first we are multiplying -1 into -1, that will be -1 and single digit will be fixed here. Remember that. And the cross subtraction 9 minus 1 will be 81 is my final answer. In this case, -1 into -2, that will be 2 and the single digit will be fixed here. 8 minus 1, that will be 7. So 72 is my final answer. And look at here, minus 2 into minus 4, that will be plus 8. And the 6 minus 2 will be 4. So 8 times of 6 will be 48. And minus 2 into minus 2, that will be 4. And 8 minus 2, or this 8 minus 2, that will be 6. So 64 will be our answer. Minus 1 into minus 1, that will be 5 here. You can take 9 minus 5, that is 4. 5 minus 1, that is also 4. So you can write 45 here. So in this way, we can easily find the multiplication problem based on the Nikhilam method. Okay, right. Let me take some more examples here so that you can easily understand. Right. So let us see the proof. First example, I taken 9 into 7. Yeah. So these two numbers are very nearest to 10. Swamiji given the proof simply way, but I will explain you. So this is 10 minus 1, then only it will be 9. And it will be 10 minus 7, then only it will be, sorry, 10 minus 3, then only it will be equal to the 7. This will be 9 times of 7. After that, 10 into 10 minus 1 minus 3 plus minus 1 into minus 3 I taken. Here, very important point we have to observe. First of all, if you take this as a pair, then that will be 9 minus 3. Am I right? Plus 3 we are getting. Or 10 into, if you can take this one, like 10 minus 3, that is 7. Then minus 1 will be left. You can take this and plus 3 we are writing. So 9 deviation will be minus 1, 7 deviation will be here minus 3. And Swamiji was taking cross subtraction or cross addition. You can see this is a 9 minus 3 you are getting here. And this is 7 minus 1 you are getting here. And after that, I mentioned that answer divided into two parts. So left part will be fixed number of digits. Suppose 12 into 10, that equal to, sorry, plus 3 I am taking. And 12 into 10 plus 13 I am taking. This will be 120 plus 3. Here it will be 120 plus 13. Observe very carefully. Single zero we have, this is replaced by 3, then we are getting 120. Here single zero we have and it is replaced by 3 and then we are getting 13 differently. That means how many zeros we have, that always replaced by the digit from the unit place of the addend. So here only single zero we have, so that this digit will be fixed there. So that is the reason we are fixing the number of digits in the right hand position, right hand part. I hope you understand this explanation. Okay, right. Let us see some more examples here, and which are based on the again base 10. Let me take some two example, and remaining two you can solve it. It is 8 into 5 and 7 into 5 and 6 into 6 and 6 into 5. These are, and this is the base 10 problem. That means the left hand side part must be a single digit. So minus 2 into minus 5, that will be 10. Only single digit we have. So that is the reason next digit will be carried forward. And cross subtraction, you can take 5 minus 2, that is 3. So after that, if you add the extra digit from the right hand portion to the left side, then it will be 40. And here it will be minus 4 into minus 5, that is 20. Okay, and 5 minus 4, that will be 1. The extra digit will be carried forward so that it is become 30. Here it will be 16 and the cross subtraction that gives 2, so that totally it will be 36. Here it will be 15 and 5 minus 7 minus 5, that will be 2, and extra digit will be carried forward, then it will be 30. So in this way we can find the solutions. And let me take here examples and based on the 100. Okay, right. So here 93 into 92, here I am taking this problem. First of all, we have to find the deviation here. So what is the deviation? I told you. First of all, we have to take the given number and we have to subtract this number from the base. So every problem and every multiplication and multiply very nearest to 100 here, so that we can subtract it from the 10. So it is minus 7, it is minus 8 it will be. So minus 7, minus 8 we have to write in this way. Okay. After that, we are multiplying these two things so that we are getting 56 in the right part, and a subtraction 92 minus 5. Okay, that will be 85. And see, this problem based on 100. So 100 having two zeros, so two digit will be fixed. There is no need to carry again here. Okay, I hope you understand. Let me solve 2-3 examples from the given below examples. Remaining you have solved it. So this is the 91 into 91. So that will be 81, and the cross subtraction will be here 82. Okay, already this problem I solved there. And this one will be 49, that is deviation product, and subtract from 93 minus 7. So that is 86. So 86, 49 will be our final answer. In this case, if you see, minus 11, minus 5 are the deviation. So 55 will be the product. And the easiest one will be 89 minus 5, that is 84. So 8455 will be the our final answer. So in this way, you can solve the remaining problems. They are homework for you. Okay. Now let us see some more examples here. And again, here I am taking the carry port. Suppose here you see, let me take this example, that is 25 times of 98. And here I took base as a 100. Then 25 is 7 minus 75 less than the 100, and 98 is minus 2 less than the 100. Am I right? So that subtraction, which one is it? This one is very easier. 25 minus 2, that is 23. And the product 75 into 2, that will be 150. But base have two zeros, so two digit will be fixed, and this one will be carried forward to the left part. And then 23 into 1, that will be 2450 will be the our product. I hope you understand. The remaining two problems you have to solve it. And these examples are based on the 1000. Okay. And look at this example, 80 888 into 998. Okay. So deviations we can find given number or these two, and the working base will be 1000. Working base means we are working on this. That is the reason we are calling working base. So then if you see in this case, finding the deviation very difficult, but I already told you we are using Nikhilam Navataha Charman Dashataha. That means first number from 10, next number from the 9, and the next number from the 9. But 1000 is the bigger digit, so that is the reason we are putting the minus. Here also 2, next from 9, 0, next from 9, 0, and this will be negative y because 1000 is the bigger number. So in this way, we can use the Nikhilam Navata Charman Dashata here. Okay, right. After the simply here we can multiply the deviation, then we are getting 224. And the subtraction 888 minus 2 is the very easier, so that we are getting that this is the product. I hope you understand this. And come to this problem, this is nothing but 1112 into 998. So 11 deviation, if you find the deviation I am talking about, the first digit from 10, that will be 8, next digit from 9, that will be 8, and the next digit from 9, that will be 8. So this is the deviation, and here it will be 0, 0, 0. So 2 is the deviation here. And if you multiply deviation, these two numbers, and 1000 having three zeros, so first three digit will be we are fixing, and the next digit will be carry forward. And the easiest subtraction, cross subtraction is 112 minus 2 is the easiest one. So then we are getting 110. And when you are adding the carry number to the 110, the left part, so the left part will be 111 and the right part will be 776. Therefore, our answer will be 11. 776 will be the product of the 112 into 998. So this is our final answer. Remaining problems you can go through it once. Okay, right. Now, so far we are seeing the deviation are given numbers, deviations are negative and the given numbers are less than the base number. But that will be the comes under one case. This is another case. That means here the multiplication and the multiplier are more than the base. And look at here, let me take this example so that you can easily understand. So 16 into 12. So these two numbers are very nearest to 10. Okay. Let me talk about only so far base number. Later we will discuss the sub base number. So here 16 given number minus 10 that will be plus 6 and the 12 minus 10 that will be plus 2. So now in this case the deviations are positive. Okay, you can see. And simply we are multiplying 6 into 2. So let me write the 16 deviation plus 6 and 12 deviation is plus 2. So answer is divided into two parts. So the base is 10. So only single digit will be fixed here. And a 6 into 2 that is 12 and 1 will be carried forward here. And the cross addition, why? Because in the previous case we did a cross subtraction, why? Because deviations are negative, but in this case deviation are positive. So 16 plus 2 that will be 18 here and 1 will be carried forward, so that 16 into 12 that gives us 192 will be the our final answer. Okay, in this way you can go through all these examples. You have any doubts you can comment in the chat box. And look at here, this is a problem. Look at this one. So that problem is 1016 is multiplied with 1006. And look at these two numbers are very nearest to 1000. If you find the deviation of these numbers minus 1000, that equal to 16. And 1006 minus 1000 that equal to 6. Sorry, first number will be 16, next number will be 6. So 1016 deviation is 16, 1006 deviation is 6, and these are the positive. And we have three places here. Why? Because base having 3 zeros. And if you multiply these two numbers, then you are getting only 96. But how many digits we needed in the right hand position? 3 digit we needed, but we got only 2 digits. So we have to make it as a 3 digit. So that is the reason I am putting the 0 here. So 096 will be the 3 digit answer of the right hand part. This is a very important one because so far I have not deal with this kind of problems. Okay. And after that, if you just simply adding the 116 into 6, so then we are getting 1022. So final answer will be 10222096 will be the our final answer. And simply Swamiji given here proof also. In this case, if you see first problem here, it will be the first problem you can see, that is 12 into 11. So 10 plus 2 that is 12 and 10 plus 1 that is 11. That is nothing but 10 into 10 plus 2 plus 1 plus 2 into 1. The same explanation we have previously. There we have subtraction. In this case we have the addition only. Remaining properties are remain same. There is no change in it. So whatever problems I'm not solved here, so take the screenshot of that and you solve it and verify whether you are getting the correct answer or right. And now, so far, we are seeing that the given numbers are below the base and above the base. Now, let me combine those things. So, in this case, the Vinculum concept is used here. So, Vinculum video already uploaded in my channel. So, go through it. If you don't know the Nikhilam, then I will discuss in a different way. And Nikhilam Navata Charam Dashata I am going to use here. Okay. Okay. So, Vinculum concept is introduced here. So, look at the first example. That is 12 into 8. These two numbers very nearest to base 10. So 12 deviation is plus 2 and the 8 deviation is minus 2. So when you are multiplying the deviation, that will be minus 4 we are getting. So if you put -4 like this or over bar like this, both are same in Vedic. So that is the reason I am saying first go and watch the Vinikulam method, then come. Okay. And here 12 minus 2 or 8 plus 2. In the both case, we are getting 10. So I am taking 10 here. Now this is not original answer because it's 10 minus 4. This is a Vinikulam number. This is not a original answer. Okay. Simply what I am saying here, observe very carefully. This problem based on 10. So only 1 0 we have. That means only one digit will be fixed here. Only one digit. So subtract 1 from the left hand part. Then we are getting 9. That 1 is nothing but tens. Only 110 you are selected. Only 110. That 110 you added here. So that you are getting 6. So 96 is our answer. This is the one way. Another way is we need only single digit here. So we are fixing the single digit. So first digit from 10 you have to subtract. It is -4 we have. So then it is +6. And you have to subtract 1 from the remaining part. Whatever remaining part will be there, just to subtract 1 from that. Then we are getting 19. If you are not understand, let me discuss some more examples so that you can easily understand. 108 into 97 is. So deviation is 8 and here deviation is -3. So -24 I got. Okay, -24. And this is a subtraction very easy. So 105 I am getting. And this problem based on 100. So 2 digit will be fixed here. So I am fixing the 2 digits. I hope you understand. After that, answer will be 105 and 24. First, when we have the Vinikulam number, first subtract from 10, then you have to write 6. Next number from 9, then you are write 7. And whatever left remaining number is there, subtract 1 from that number. So that 104 you are getting. So this is our final answer. This is a simple way you can understand. Suppose, look at this problem. 1026 is multiplied with 997. So this is a 1000 based problem. That means 3 digit will be fixed in the right hand position. So deviation is +26 and here -3. Deviation product will be 78 bar. And the left hand part will be subtract this one. This is a easier one. But we already know that we have the 3 digit here. So but 1 digit is left or less. So we have to put the 0. That is also a negative. Now 1 0 2 3 0 bar 7 bar 8 bar. Okay, whatever bar digit will be there, you apply Nikhilam Navata Charman Dashata. From 10 it will be 2, from 9 it will be 2, from 9 it will be 9, and subtract 1 from the remaining number. So that is 1 0 2 2 will be the our final answer. I hope you understand. So solve this problem and this problem. So in this case, you see this is a 10,000 based problem, but the product we are getting only single digit, but we have the 5 digits. So every digit we are taking as a 0 to make 5 digit number in the right hand position. And this is total number is negative number. So when you are taking the negative number, applying all from 9, last from 10, then we are getting this is the product, and subtract 1 from the left part. So then we are getting this is the left side answer. I hope you understand. Let us enter into some more concepts. Right. Now, so far, we are seeing that the problem are based on the base number. But in this case, we are working on the sub-base number. Look at here, 49 into 49. So these two numbers very far away from the 100 and 10. But these two numbers are very nearest to 50. So 50 comes under the sub-base number. So when 50 comes under a sub-base number, we can find the theoretical base from the 50. Okay. What is the theoretical base? So that is nothing but 5 into 10. So this is the base is called theoretical base. That means it is the indicates number of digits in the right hand position. Or else you can write 50 as half of the 100 also. Half of the 100 also means the number of zeros in the 100. This is a theoretical base. It is indicates the number of places in the right hand position. So this is the theoretical base. Now that is the reason I told you sometimes base is called theoretical base. But the working base is 50 only. Working base is 50. Working base means we are finding deviation by the working base. So 49 minus 50, that is minus 1. 49 minus 50, that is minus 1. You can see solving is simply written minus 1 and minus 1. Okay, first let me take this part. Okay, this part. That is half of the 100. So half of the 100 means when you are multiplying these two numbers, minus 1 into minus 1, you are getting only 1. But theoretical base is 100 here. So that means we need 2 digits. So that is the reason we can write 0 and 1 here. And after that, by the cross subtraction, we are getting 48. So directly we cannot write 4801. This is not the correct answer. Why? Because it is the half of the 100 base. So that is the reason when you are taking the multiples, k value you are taking, that k value is always multiplied by the left side answer. Right side never affected, only left side answer. So that means every time whenever you are taking the sub base, the k value you have to find how many times it's multiple of a theoretical base. Here k times is 5. Here k is half of the value. So simply Swamiji dividing the half, that is 45, 48 divided by 2. Why? Because k value is here half. So half of the 48 will be 24. Now this is the our perfect correct answer. This is the one way. Now if you are taking only base 50, base 50 means here the k value is into 5 times. Okay, here it will be half of the 48 is 24. Here it will be k times of 10. See, the product will be minus 1, but theoretical base is 10. So that is the reason single only digit I'm keeping here. And deviation subtraction from the given numbers, that is cross subtraction or cross addition. In this case, cross subtraction. So 48 now, this is multiplied by k, that is 5 now. So then that is 240. So 24001 will be the final answer. And look at here, some more examples Swamiji taken. This is the half of the value. That means here 42 we are taking multiplied with half value, that is k. That is 21 we are getting. Look at here. So 100 is a theoretical base. So that is the reason 2 digit will be fixed here. But when you are taking the base 50 value, so see the product will be 16. It is nothing but based on 10. So single zero we have, so single digit will be fixed. The extra digit will be carry forward so that we are getting 42 plus 1. If you are writing like that, that means your answer become wrong. Why? Because the left part is multiplied by the 5. Then you are getting 210. After multiplying by the k value, then only how to add the carry forward number to the left hand side. Remember this point. So that 6 will be in the unit place and 1 will be added to the 210. So that 2116 we are getting. So 46, that gives us 2116 is our final answer. Okay. Now let us take some more example. Yeah, look at here. So here theoretical base 10. So the left hand is 5 multiples. So the left hand part is multiplied by 5. But theoretical base having only 1 0, so 1 digit will be fixed. When we are added to the extra number to the left hand after multiplying with the k value. So that 4 and 40 plus 5 is 200. After that, we have to carry the 2 to the left side. So that 2024 will be the product of 46 into 40. Here also you can see 46 into 42. In this case, k value will be half value. That means this 40 into half, if you are taking, that is equal to 20. So 20, and we are taking 100 as a base. The product will be 25. Remains same because your theoretical base having two zeros in this case. Yes, I hope you understand. Let me take some more example. Yeah, look at here. Now in this case, when we are using the sub-base concept, in this case we are getting the vinculum numbers. So how we can deal with vinculum numbers? Let me give some more two examples to understand the concept. Here, theoretical base is 10. So let me write here 54 plus 4, 46 minus 4. So the product will be minus 16. And here it will be 50. And in this case, you are taking 5 multiple. So simply you multiply with 5. Then you are getting 250, 6. And remember one point here. You have to remember one point. When you are taking the theoretical base 10, only single digit will be fixed here. How much digit? Single digit is fixed. That means this is the extra digit will be carry forward. That is the extra digit will be carry forward. So whatever I told you so far, first find the complement of the only first digit. Why? Because we need only single digit. So from 10, it will be how much? 4. And just you subtract 1 from the left part, I told you already. But this extra digit also should be added to the left part. When you are adding minus 1, that is totally minus 2. So 150 minus 2 and a 4, that is 2484 will be the our final answer. Is it clear? Okay. And in the second example, of k value I am taking 1 by 2. Let me explain you once again. 150, 1 bar, 6 bar. We want only single digit. So all from the last one 10 we are applying. So then we are getting 4. Already told you subtract 1 from the left part. But this is also carry number. So when you are taking minus 1 again to the left part, so totally they are minus 2. That is the minus 2 I subtracted here. Is it clear? Right. Now here half of the value. So 50 here I am talking about. Half of the value will be here 25. So 25 I written. And the product will be here minus 16. And now see, now observe very carefully. Having two zeros, my theoretical base, so two digits are fixed. Now from 10, it will be from 9, it will be 8. See, how many digits I am fixing? I am applying on that Nikhilam Nohata Termanduseta. And from the, when you are converted the selected digit, subtract 1 from the left part. So that you are getting 24 is the final answer. Okay. I hope you understand. Let me talk about some more examples here. Yeah, this is also a good example. In this case, you can see base 10 we have. So only single digit is fixed. And 17 into 4 is 280. After that, this 17 is totally added to the 28. Remember that one. So in this case, if you multiply this part, so then you are getting 324 you are getting. So, but remember one thing here, this is a problem based on 60. Only single digit we want. So single digit you are selected. So all from 9, last from 10. Formula if you are applying on this, so then you are getting 6 only. And subtract 1 from the left part. But this is also carry partner. This is also added to. That means 300. This is minus 1. This is minus 2. Totally minus 3 we are subtracting. So that 297 we are getting. Here we have the 6. So this will be the our final answer of the given question. Okay, is it clear? Right. So here also different examples Swamiji was taken. That is 250. 250 we can write 25 into 10 also, or you can take this is a 1000 into 1 by 4 also. Okay, why? Because here theoretical base is 1000, here theoretical base is 10. In the both ways you can solve, but this is when you are taking theoretical base as a 10, then it will be complicated. You cannot take like this, like 500 by 2. Why? Because it is not a theoretical base, it is a sub base. You can take like this, then 100 into 5 by 2. In this way you take, then this is the k value and this is the k value. Here it will be the k value. That means here when the fractions coming in a different way, that give the answer also correct, but it will be take mucher time compare with this part. Swamiji taken 249 into 246. So working base is here 250. Working base is 250. So from 250 deviation -1 -4 is written. But 250 I am taking as like this. That means the left part is multiplied with 4. So if you subtract this value, then 245 we are getting. Okay. After that, if you multiply these two things, then you are getting 4. But theoretical base is 1000, you can see. That means 3 places are fixed here. So I can put 0, 0 here. And if you see, when you are dividing 245 by 4, then you are getting 61, 1 by 4th we are getting, and 004. So it is not a correct answer. It is not a correct answer. Okay, then simply what we have to do here, I will tell you one simple example to understand the concept here. 2432 is there. If I take the value up to this, then this is nothing but 24 hundreds. That means 24 hundreds it is called. Then these two are the comes under a different tens. Or you can take this is our 21 ones also you can take. Then also it is comes same meaning. That means here it is 61,000 actually. Okay. 61,000. Why? Because we are taking here 1000 base. So this is the 61,000. Why? Because in the formula we are writing like this. Did you remember or not? I don't know. So this is the base value. So this is the 1000 it will be. So 61,000 actually. But this fraction is indicates the not thousands. There indicates like tens, ones, that kind of problems are hundreds. So that means this part is must be come to the right hand side only. That because they are belonging to that. So this is a 61,000 we are writing as it is. So that is the reason we are fixing the 3 digit. Okay, fine. But what about this fraction? So this part is multiplied by C. This is multiplied by 1000, and this is 61 upon 1 by 4. So this into this one is 61,000. Okay, and 61 into 1000, that is 250. So that is the 250, not the thousands. They are hundreds. So thus 100 is added to this part. So that 1 by 4th of 1000. Simply whatever fraction we are getting, that fraction into theoretical base. Remember this point. That is 1000. 250 we have to add here. So that we are getting 254 is our final answer. So 61,000, you see 3 zeros. So 3 digits are fixed. Okay. Let me take here another example. Here 209 is divided by 4 and 240 is there. So here if you divide in this number, so 52 1 by 4 you are getting and 420. This problem. Okay. So 52 And this is the nothing but not the thousands, they are hundreds. Okay. So 1/4 of the theoretical base 1000, that is 250 we have to add to the this part. Okay. Then 250 when you are adding to the this part, that will be 670 is our final answer. Okay. Is it clear? Suppose this part comes like that 3/4. Then simply again multiplied with this one. So totally we are getting 750. Then 750 how to add to the right part? It depends on the problem. Okay. Right. Let me take here one more example. Yeah. So these two problems are based on the like a sub base 700 and 700. Okay. Same procedure, same concept. There is a no change in it. You can go through it. You can understand very well. Okay. You can take the screenshot. Any doubts? Comment. Here the first problem we are taking nearest to 500 here. Okay. Nearest to 500. That is also taken as 1000/2. That means this is part is divided by the 2. Then totally how much we are getting? 318/2. So this is the half. Half of the theoretical base is nothing but 1000. So that is 500 is added to this part. Then we are getting this one. Okay. Here look at one. Half of the theoretical base is 100. Okay. Half of the value theoretical base is 100. But remember one. Yeah, let me discuss this problem. Is very nice problem. Is from 50 I am talking about. This is working base. So 32 is the deviation. 45 deviation will be 5 minus 5. So 50, and I am taking this is the half of the 100 means 2 digit will be fixed here. So let me fix the 2 digits here. And here it will be 13 half of 13. So that is 6 1/2 and 160 we are getting. Okay, right. Now see, in two ways we can actually solve. First thing, half of the theoretical base 50, if you add to this part, totally 160. So that we are getting 210. But we need only 2 digits, so you can carry this part, so that it will be 810 is the final. This is the one way. Or 6 1/2, 601. First you carry this part to the whole number, then 7 and 60 you are getting, and this is the half you are adding here, so that is plus 50. So 7 1 1 10, again 2 digit we need, so again this carry the number 110. So I think this is the easier one, you can choose this one, there is no need to follow this. Okay, right. Here also one problem is given, that is 389 into 516. You working on 500 and half of the 1000 is taken. So try to solve this problem. Okay, right. Right. So now come to colliery pots. I mean, some related concept. So in this case, Swamiji using Nikhilam Nahota Charmam Dashata concept. Along with that, further extension of that is nothing but Yava Dunam Tava Duni Krutya Vargancha Yojayat. It means whatever the extent of its deficiency. Deficiency means either positive, negative deviations. Okay. Further, we have to square up the deviation. That means, let me take some examples. That means simply if you understand the formula meaning, Yava Dunam Tavi Druni Krutya. That means how much deficiency is there, whether positive or negative deviation. We have to square that number. Okay, we have to square that number. For example, look at here. So this is 11 square. It is very nearest to 10. So from 10, deviation of 11 will be 1. Okay. So 11 square is equal to Whatever deviation is there, we have to add to the given number and square the deviation. So that 121 is our final answer. See, single zero we have. So single digit will be fixed in the right hand position. It will literally look like the same thing. Why? Because this is nothing but 11 plus 1 by the cross addition, and this is the product. See, 1 into 1 is 1 square. So Swamiji representing this total concept in this paper, especially square concept. Suppose 14 square is there. 14 square is nearest to 10 base. So deviation is positive 4. So 14 plus deviation and the deviation square. What is the formula? Given number plus or minus deviation plus or minus deviation square. This is the square of the given number. Given number square. Okay. So that is 18. 4 square is 16. But it's based on 10 problems. So single digit will be fixed. Extra one will be carried forward. So 196 we are getting. Same rule we are applying. There is no change in it. And suppose look at here. 94 is there. Okay, 94 is there. In the 94, it is based on 100 problem. So deviation will be minus 6, that is negative. So that we are finding square of this number. So 94 given number minus 6 in this time and minus 6 square. So that here it will be 88 and this one will be 36. I am writing as it is because of a 100 having 2 zeros. So 2 digit will be fixed in the right hand part. So I am fixing like that as it is. Suppose 108 square, if you see, same problem, deviation here it will be positive 8. So 108 plus 8 and 8 square. So that here 116 and 2 digit we have to fix. So 8 square is nothing but 64. So this will be the square of the number. And look at here, 989 square. Okay. This is the nearest to the 1000. And deviation, if you want to find, simply take complements. Sorry, all from 9, last from 10 if you apply. So this will be 1. This is also 1. This is also, here it will be 0. And it will be negative. Why? Because it is less than the 1000. So 989 minus 11 and minus 11 whole square. So 9, 7, 8 and 121 we are getting. 1000 having 3 zeros. So we can fix the 3 zeros. So we can write 978 121 is the final answer. This is the first coloring. Okay. Right. Let us see the second one. So in this case, Swamiji using Eka Adhikena Purvena along with a different form here. Okay, look at now. Ekadikena Purvena Swamiji is using. That means here, especially any number, okay, any number ended with 5, then we can easily find the square of it. Okay, what is we are going to find? Square of that number. Suppose look at here, Ekadikena Purvena Sutra using. Ekadikena Purvena means one more than the previous one. Suppose 35 square we want, 45 square we want, 95 square we want. So in this case, answer will be divided into 2 parts. Okay, in the same way. And except unit place digit, whatever remaining digit will be there. Take successor number. It means Ekadikena, one more than that number. That is 4. And 3 into 4 we have to do. And here it will be 5 square only. Then 12, 25 is our 5 answer. Here it will be 4, next number will be 5. We are multiplying Ekadikena, multiplying with Ekadikena and a 5 square. That means here we are getting 20 and 25. In this case also 9, its next number is 10 Ekadikena and the 5 square. That is 90 and 25 will be the our final answer. Suppose 1115 square is there. So just you cancel the first digit and you see 11 is there. 11 is multiplied with its next number 12 and a 5 square. So that is 132 and 25 will be the our final answer. Yes, are you getting my point or not? Suppose 195 square is there. So 19 is multiplied with its next number 20 and 5 square. So that here see 0 and 19 twos are 38 and 5 square is 25. So 38025. 38,025 will be the pair of the 195. Okay, right. Let us see the next one. Right. In this case, Swamiji using another one more formula. That formula name is actually sub-corollary of the previous one, based on the Nikhilam Sutra. Okay. The formula Swamiji using here, Antyayora Dashakepi. Antyayora Dashakepi means, suppose 96 into 94 is there. Then Swamiji using Ekadikena Purvena here. What is the Antyayoha Dashakepi? Dashake api. It means first unit place sum 10, remaining places must be same. For suppose 37, 33 multiplication. Sum is 10 and the remaining digits are same. In this case, 6 into 4 is 24 we have to write. Product of these two numbers. And what is the next number of the 9? Next number of 9 will be 10. Next number of 9 will be 10. So that is 9 into 10 will be 90. So this is our final answer. So 7 into 3 is 21. Next number of 3 will be 4. So 4 into 3, you can see 4 into 3. So that will be 12. So this is our final answer. Suppose 114 into 116. Here sum is 10. So that 24 we can write directly their product. And the remaining place digits are same. So the next number of 11 will be 12. So 12 into 11 will be 132. This will be the final answer. And Antyayoha Dashake Api, I'm saying Dashake Api. Dashake Api means it is a multiple, like a multiple of a 10. So far we are seeing that 79 into 71. In this case, the sum is 10. But sum also 100. The first two digit sum is 100. Antyayo Dasha. Dasha means 10. K api, it is multiple. Okay. Sum is multiple. So 10 multiples also we can take and we can apply same formula. So 91 into 9, that is 819. And the sum is 100. So that is the reason we are taking the product of 91 into 9. And the remaining places are same. And next number of 1 is Ekadikena is 2. So 2 into 1 is 2. So this is our final answer. You thought? No, it is not a final answer. Why? Because there is one reason is there actually. Okay, it's not easy. So whatever you think. Okay. Right? When you are increasing the places, see here you are taking 10, then we are taking 8 and 56 we are writing. When you are taking 1000, you have to take the left part as a multiple of 10. When you are taking 1000, it is a multiple of 100. Like that you have to take, then only it will be the correct. So 2 times of 1 is 2 into 10, that is 20. So 20819 is our final answer. Let me take here 793, 707. See, the sum is 100 here. So you can take direct product of that. So that is 21, 63, 65. This is the left part. And this part is next Ekadikena of 7 is 8. 8 into 7 is 56 is a multiple of a 10. When you are 100, take one multiple. 1000, two multiples. That is 2 multiple of 10, 100, like that. then is our 560651 will be the our one answer. And you can see when we are getting the extra digit, that should be carry forwarded. You can see in this example. Okay, you understand? Right. So the next type is Swamiji use Eka Nunena Purvena concept here. This is a multiplication with mono digit, that is nines, multiplication of any number with nines like this. Okay, Swamiji using Eka Nunena Purvena concept here. In the first case, if you observe very carefully, Swamiji multiplying the multiplicand with multiplier. Here multiplier are nines. So number of digits in the multiplicand and multiplier are same. You can see 4 digit, 7 digit, and here also 7 digit. Here also 7 digit, here also 7 digit. In this way, when we have the numbers like this, and as Swamiji was explained here by the Nikhilam method, just a demonstration. But when we have the nines, there is no need to use this method. Polari, that is Eka Nunena Purvena, that is one less than the previous one, that we can use instead of this concept when we have the nines. So 777 into 99 when we have, simply subtract 1 from the multiplication, from this one, not from nines. That is 776 you are getting. That is the reason Swamiji using Eka Nunena Purvena. After that, just you write the complements of the 776 from 9. From 9, it will be 2. That means the sum is 9. You can see here also it is 2. The sum is 9. Here sum is 9. Then it is become 3 only. So 776223 will be the our final answer. Let me take here one more example. 103,579 into, must be number of 9 same only. Then only we can write like this. First, whatever number will be there, just you subtract 1 from that number. So that how much we are getting? 1, 2, 0, 3, 5, 7, 8. After that, you can just write the complements of the each and every digit. That is one complement from 9. Here not using all from 9, last from 10. You can use all from 9, last from 10 in a different way. I will show you that. First, let me talk about all from 9. Only all from 9. All from 9 I am talking about. First digit from 9, 8. Second digit 7. Third digit 9. Next digit 6. Next one is 4. Next one is 2. And 8 will be 1. So this is the our final answer. Suppose if you want to use the all from 9, last from 10. Suppose if you want to use that formula, then we can do one thing here. What we have to do, let me tell you, just to remember that one. Okay. For that, just you subtract the 1 from the given number as usual. That is 1, 2, 0, 3, 5, 7, 8. After that, just you subtract from 9. Okay. From 9, that is 8. From 9, from 9, from 9, from 9, from 9, but last from 10. That is 1. In this way, we have to use all from 9, last from 10 here. Suppose 24,3 into 9999 if I am taking like this. In this case, number of digits not equal to the nines. Then just you put the zeros here so that there is a no change in the multiplicand. Then it look like a previous problem. So subtract 1 from this multiplicand. 0, 0, 2, 4, 2. After that, just you apply all from 9, last from 10. So that is 9. Here also 9. Here also 7. Here it will be 5. From 10 it will be 6. Sorry. From 10 it will be 7. So this is our final answer. That means you can use either all from 9s or you can use all from 9 last from 10 also. Okay, right. Now let us see the next one. Yeah, this is a very interesting one. Let me take more time on this. This is here 43 into 9 is taken. It is all in many way, but Swamiji was explaining in different way. Let me talk about that. So 43 into 3. Okay. Swamiji was separate like this. How is separated? How many nines we have, that many digit we have to select from the unit place of the multiplicand. Suppose 112 into 99 is there. In this case, two nines we have. So first part we are taking two numbers. After that, we are writing one. We are separating like that. In this case, I'm explaining only this one. You can solve this problem in many approaches, but my special intention is that only discuss about Swamiji book. Okay, if you want another approaches, you can go through my YouTube. You will get many videos. Okay, after that, Swamiji is saying that whatever number of nines and number of digits we are selected, the rest of the digit will be there. The rest of the digit. We have to increase 1, that is plus 1. Then it is become 53. That 53 we have to subtract. That 53 we have to subtract. So when they are minus, okay, 53 we have to subtract. So here it will be 13, so it will be 8, and it will be 3. Okay, are you getting my point? And write the complement of the digit from 10. Then it will be 3. So 387 will be the answer. Swamiji was explained like this. Okay, I understood this in this way only. Here also you can see single 9 we have, so they are separated single, and the rest of the part is increased by 1, so that he subtracted 7 from this number, and 3 he writing as it is, and complement is 7, and take 1 borrow from the 6, so that we are getting 13. So 6 will be the final answer, and it will be the 5. Here it will be observed very carefully. This is a very important actually. The first digit complement will be 8 is written as it is. After the Ekadikena of the 12 will be minus 13. So from taking the borrow 1 from that, so 12 means 9 we are getting. Here it will be 11. 11 minus 1 will be 10. That means this is the part only subtraction part, and this part only complement part. Okay. Suppose, right, 11119 into 99 is there. In this case, first we have to select two nines. For these two nines, we have to write the complements. So that is the reason he writing here, and just you write the complement. From 10 it will be 1, from 9 it will be 8, all from 9 last from 10. That will be completed. After that, whatever number it will be there, that should be subtracted. That is 1, 1, 12 totally that value. Okay. Then it will be 7, and this will be 0, and here is this column 0, and 11, 11 will be the final answer. I don't know why Swami is explained like this, but this is one way. Actually, we can approach it in different ways. Suppose 11119 into 99 is there. Same thing. First selected two digits, these two digits. Just you write the complement of that one, 81. After that, 11119. From that, you subtract whatever non-selected digit will be there. That is 1112. You can write directly like this instead of writing twice. Okay. And come to this problem. 77 7999 into 9999. In this case, if you observe 4 nines we have, so 4 digit will be selected. So 49999. That means we have to apply the complement on this number only. So remaining digit will be 77. So 77 ekadikena will be 78 we have to subtract here. And the complement will be we are applying on this number. From 10, 1, from 9, 0, from 9, 0, from 9 it will be 2. And subtract 78 from this whole number, so that we are getting 1, 2, 9, 7, 7, 7 will be the final product of this number. So you can remaining problem also, you can go through like this. Okay. Thank you.